Sure, thank you.
Hey everyone, we're DIDO Solutions and we're happy and excited to tell you about what we're working on and who we are. I'm Ian Stavros.
I'm Nick Stavros.
And I'm Brian Turek.
Okay, who is DIDO Solutions? DIDO Solutions is able to provide companies and developers with easy-to-use, scalable, testable, and simulatable virtual distributed systems within seconds, where each virtual node can become a digital twin representing any hardware or software found within a real system to test interoperability before release. And this is important because it's virtual, so you can spin it up quickly. You don't have to be spending a lot of time in the lab building things. Next. What is DIDO? Distributed mutable data objects refers to underlying technology supporting distributed data and computation across the distributed networks of peers using consensus algorithms to maintain integrity and consistency across the network. So this is our abstraction term for all of those things. We got tired of writing blockchain, distributed ledger technology, blah blah blah, DLC, whatever it happened to be. So we came up with the term DIDO. Next. What is a reference architecture? We built the reference architecture. I wanted to take a few seconds to describe a reference architecture. It is defined as a set of goals. It provides common language for various stakeholders. It provides consistency of implementation of technology to solve problems. And it supports the validation and comparison of implementations. And that's really important because what we found out is a smart contract is not a contract, and it's not smart, and a ledger is not a ledger, and et cetera, et cetera. So you need to have a common vocabulary and really formalize and stretch those things out. Encourage adherence to common standards, specifications, and patterns. I think we've identified, I think it was 102, 105 different standards that are applicable in the DIDO world. Next slide. Distributed immutable data objects reference architecture. So this is where we took the concepts of a reference architecture, which was originally provided by the DoD, and we applied it to DIDO. The DIDO concepts captured within the reference architecture are intended to represent any architecture relying on distributed networks of peers that store data and allow parallel computation. The DIDO RA is not intended as a physical must-have or must-build architecture. It is more of a requirements list and things that, especially you in the government, if you're going to specify something, you really need to look at some of the stuff in there on requirements and functional requirements and non-functional requirements. And this is not saying you will have this requirement, you can just pick it up and stick it in your contract. It's just a good place for you to be able to come and get definitions and make sure everybody's on the same page. Next slide. What it is, distributed data service, DDS. It is a family of specifications for published subscribed data distribution systems. It provides a common application level interface, clearly defining the data distribution service, platform independent model, the PIM, that can be then mapped onto specific languages. So if you use DDS, you define your system and in a platform independent way using IDL, interface definition language, which is an ISO standard. And then from that, it generates the C or the C++ or the Java or the JavaScript or whatever you need from that language. And that ensures that all the language APIs and things are consistent. Mark kind of alluded to that. Sometimes you get left-handed and right-handed thinking, and somebody reads it and gives you a glove, but it's for the left hand, and you were reading it right-handed. It doesn't work. So that's why this is important. And we chose DDS because it is a distributed system that's up and running. There are 14 different vendors or 15 different vendors that produce the product for it, and it is distributed. There is no central server within the system. Next slide. And so one of the important parts about the DIDO reference architecture is it contains a governance model. And a governance model is really important if you're going to try to move forward. As I said, we're going from the age not only of central or decentralized software, we're going to distributed. We're doing the same thing when it comes to management and governance. And so you have to govern, you can't manage, you can't lead, you can't direct, so to speak. So a community of interest is a collaborative group of users who exchange information in pursuit of their shared goals, interests, missions, or business processes, and who therefore must have a shared vocabulary for the information they exchange. The group exchanges information within and between systems to include security domains. And we introduced something called an ecosphere, which I don't think you've ever heard of before. It's something that goes above ecosystems. It's the highest level community of interest that encapsulates DIDO ecosystem communities and DIDO domain communities. And generally, it is the legal entity or the source of funding, the umbrella organization that then people go off and start building things on. And you'll see an example that we came up with later on when Ian speaks. But that's where you would have a consortium of people from different agencies coming together, other transaction authority come together, and they'll create an ecosphere. The ecosystem is the mid-level community of interest that encapsulates DIDO domain communities. The ecosystem has a subcharter approved by the ecosphere. So you want to build an ecosystem, you have to go to the ecosphere and say, yep, I want to be part of you, and they have to agree. And you have to live by the legal documents, this charter, the policies and procedures, and all the rest of the stuff that the ecosphere has laid out. You have to do that. And then they can spawn domains or other ecosystems. A domain are communication context which provides virtual environment encapsulating different concerns and thereby optimizing communication. It's really focused about building building something, whatever it happens to be. So if we're doing blockchain, it might be a cash register, and that's the domain. You're going to build a blockchain cash register. Somebody else might be building a wallet, which is different than the register, and those are domains. And they actually produce something, and they feed it back into the ecosystem, who then coordinates and integrates those things together to make sure that that they stay within the confines of the ecosphere. Next.
Whoops, overshot. So the goal of our company is to become the future gold standard in distributed technology testing and ranking, which helps helping accelerate the adoption, interoperability, and quality of the distributed technology people want to implement. And this includes the blockchain, cryptocurrencies, DLTs, IPFS, DDS, NFTs, digital twins, and any other future distributed technology that we aren't aware of yet. On the right, you can see quite a few of the software problems that have occurred over the past decade that have cost multi-millions of dollars. And as more and more people adopt, this becomes a bigger and bigger problem as more and more people would be affected by the bug. Right now, the typical traditional way is you have to get a hardware computer and you have to set up X amount of them to represent each of the nodes in order to spin up and test the interoperability of your distributed solution. And if something goes wrong, then you have to reset everything back to a known state, which can be really hard and time consuming. Current quality assurance methods just aren't properly applied to distributed systems. So right now, a lot of people use traditional methods, not thinking of only focusing on their product. But as you become a distributed network, it can actually expand to everybody else around you. And that's why we incorporated the idea of community of interests, where, as I said, an error can compound into billions and eventually trillions as more and more people get involved with the system. Here we're trying to create a new paradigm. As you can see off to the left, there's the traditional model where you come up with the idea, the design, find the physical computers, establish a secure subnet so nothing that you do will affect what you're working on, configure physical computers, and then install the platform, start up the computers, start up DIDO, and so on and so forth. Or we've tried to really simplify and take out quite a few of the steps that aren't needed, like trying to find and verify the hardware that you're about to use for testing. So the DIDO solution is to provide developers an easy-to-use, scalable, and repeatable distributed technology simulation and testing solution, helping manage risk when you're in critical points within missions, and failure is not an option. You need to make sure that the technology was tested properly before it was deployed. Save time, streamline the agile process by spinning up complex virtual environments in 30 seconds, and to help you save money by leveraging virtual resources to improving testing efficiency and minimizing costly errors. Here we have our use case where we have the ecospheres, which can, for in this example, we chose to use the general vehicle architecture that NATO uses for the communication of their military vehicles. And so for an example of the ecosphere, we would have the DoD, the Ministry of Defense, and NATO. And then below that, they would each have their own ecosystems that would be land vehicles, aquatic vehicles, air vehicles, kind of focusing on, and the NATO general vehicle architecture as an ecosystem that the other vehicles would be a subsection of. Then here you would have the domains down below to test that each of the technologies that you're trying to incorporate within your general vehicle architecture works as intended. You can see we've come up with a few like radio, navigation, targeting, vehicle dashboard. One of the key things or important things about this idea is each of the DoD, the MOD, they can end up creating a node and keeping it in a black box so their technology or IP is protected. So that way it allows the people that they want to collaborate with to work with and figure out how to interface without having to actually know how everything works under the hood, which everybody knows just because they're an ally today doesn't necessarily mean they're going to be an ally in the future. Hopefully we do want that, but you never know what the future kind of holds for us. And then from here, I'll kick it off to Brian to showcase the demo.
Hey, everybody. So let me get this set up real quick. I'll try and share my screen. Is everybody able to see the screen?
Yes.
Yes.
Awesome. So as I walk through this demo, I'll try to describe a bit as to what is going on. We have current setup. For the sake of time, we've initialized our use case example in our application. So here you can see we have the Ministry of Defense, Department of Defense, and NATO ecospheres. For ecosystems, we currently have land vehicles and aquatic vehicles. So I'll walk you through going ahead and creating a new ecosystem for one of those ecospheres. So we'll do the air vehicles. Ecosphere. We'll do NATO. And then we'll do air vehicles. We'll populate it with some initial chairman, board members, maybe some license agreements that we would like for this ecosystem. We'll go ahead and create that. Now, for the sake of the demo, we've just created an ecosystem, so we'll go ahead and create a domain for that ecosystem. We don't have any initialized at the moment, so we'll go through and create it. So we'll do air vehicles for the ones that we just created. And let's say we want to go ahead and create a radio domain. And so maybe radio subsystem. In this example, we pre-populated our environment with I guess, specific types of nodes, nodes that we've already have within our system that some of them are blockchain. So you'll see a lot of references to well, in our user interface to like smart contracts and stuff like that, but we've quickly modified it to showcase this, this example here. So throughout here, we'll have like GEF nodes, which are like Ethereum blockchain nodes. But for this example, we'll go ahead and create some RTI DDS nodes. And what these are going to simulate are distributed platforms that will publish out telemetry and then subscribe to those telemetry events. And then we have a routing service for wide area networks. So I'll go ahead and start creating some of those right now. The first thing we want to do is have at least one subscriber so we can see the events happening throughout the system. Go ahead and create that. And then we'll go ahead and do the routing service so we can set up a wide area network. And then we'll do some publishers. Now, with these publishers, I'll set them up in two different modes, but for the first two, I'll just let the state be default. So they'll run from their default state. But for the other four, I'll go ahead and publisher, publisher. I'll go ahead and initialize it with a certain state. And we're simulating that right now through this configuration file. So I'll just say let's do that, and then the number that we'll start at. This will make more sense as we go through the demo.
The configuration can be anything.
Yeah,
it's just the ground state.
Correct. So now we've initialized and configured our domain, and we'll go ahead and well, defined our domain, and then we'll go ahead and initialize it. So as you see here, what's happening in the background is we're setting up deployments for each one of these nodes, and that orchestrates these nodes out in a manner that allows us to control them in different ways. So in a moment here, these nodes should populate. Currently, these nodes are running within my local development on my MacBook. But the system is designed to scale to any resources and any number of resources. So you could imagine it scaling to a cloud provider. And all right. Let's go back to that. Not sure why I didn't update there, but yeah, so you can see we've got the publishers all listed out here, and we got a subscriber and a routing service. So as these initialize, I believe it's just taken a little bit more time than I would like. But as they initialize here, we'll be able to see some information about the nodes and then logs related to those. So let's see if we can dial into it. Okay, so it is working. It's just not displaying me status for some reason. So here you can see that our publisher, this is the initial state that I was talking about before. Right now we just have it displaying some initial telemetry, which is a message of hello world, an account starting and initializing at 0. And it'll repeat up to, I think, 1,000 for this demo. But as we go into other publishers, for example, we might be able to find the state of the ones that we created. This one will be a good one. So there you go. So these publishers and the rest of the 4 publishers are all writing new communication message received, and then initialized at start 100. So then we can jump into the routing service. There's quite a bit of telemetry here, but this details all of the communication that's happening throughout the system. So we'll see if this is able to be displayed at this moment. It fills up the logs pretty quickly, so we'll see. Oh, timed out. But we can go to the subscriber and at least show the communication there.
Now, one of the things to be thinking about while this is happening in the background is that these things are all being done virtually. You didn't have to buy machines, you'll find machines, scrounge for machines. You could just spin these things up and then be able to get them to run. So even if it looks like it's taking some time, that amount of time is trivial compared to what it would take to do a real setup. We were talking to a large healthcare company, and they said that sometimes it takes them 80+ hours to get something to 96 hours to get something to the point where they can test. And then if the test is incorrect, they have to wait, get everything reset up and wait another 96 hours to test, which is a problem.
Another thing I'll add is going back to where a lot of people think it's just the same traditional stuff where they can just focus on their singular app and push the update. There was a company in 2018 called Parity who worked on the Ethereum blockchain, and they pushed an update which accidentally stole 50 wallets, equaling $50 million. They freaked out, deleted the code, and locked themselves out of the wallets and couldn't give the money back, which then led to them quickly pushing up another update 2 days later, causing another $200 million on top of that as a problem. So with distributed technology, the current idea of just the agile process of pushing an update and letting a problem be represented or communicated by the people isn't something that you can necessarily rely on, as the damage can be really devastating before you find out about it. So that's why you want to be able to have quite a few of these or being able to test it inside a virtual system before it actually gets deployed. Does it work? Or? Yeah,
so here you can see that the messages are coming in on the subscriber node. And you got these messages coming in, so we can see the custom state that we wanted coming in. You can see there's multiple nodes, so you're getting multiple numbers depending on their initialization, their starting point. And then you have the other publishers that are just giving a simple hello world. Yeah, I apologize that the demo isn't as smooth as I had hoped it would be. I don't know if you can hear my computer, but it's the fan's running on it pretty high right now. So I'm assuming that there's some I'm running into some resource issues on my laptop. Yeah, there we go.
So another one of the players that you could have introduced here, one of the node types, is a malicious player. And that malicious player, once you have everything up and running, could now be trying to hack into and attack a node and figure out what goes on. Now, when you do malicious actor testing, one of the things you don't want to do is have that malicious actor anywhere on a real system that is potentially able to connect to other real machines. And when you're done, you want to actually be able to wipe the machines clean so that nobody else actually picks up that machine and starts using it and infects the real world. Nobody wants to be that guy. So with this system, you can actually create those virtual malicious tester nodes, and they can be trying to break in or attack or figure out what they can do to hack the system. And then when it's done, all the virtual nodes go away, and you're able to then, with confidence, believe that nothing else has been damaged. You can put these on your own local machines like Brian has, which is on his little laptop, Mac, or you can put them on your own server, or you could put them in the cloud like AWS or Azure or any of those, or the government cloud. So we still are working on being able to do that. I think we're done. Ian?
Yeah, sorry. Where's the...
So while Ian's bringing up, that's a good point that Nick brings up. Again, this is in a virtual environment, and being able to have a digital twin in a virtual environment to be able to test your network and malicious software, seeing how it's going to impact your network and release it in this virtual environment. I think it's a great test, and it's just one example of distributed system testing, right? You gave the example of use case of NATO, but then you also you can test with from a cybersecurity threat perspective, and even setting up the idea within the virtual environment, what kind of network you would need to support even zero trust architecture. So there's a lot of possibilities, and when you look at this type of solution, again, having a default architecture to follow, but a way to actually implement it and successfully test it in a virtual environment, following some type of standard, I think it's a big deal.
Also, we did show you the Ethereum nodes. So what you could do is, if you're interested in seeing how you can incorporate blockchain or DDS or different distributed technologies, you can spin up a node and work on trying to figure out how you can get that to interoperate the technology that you're currently using. So with this, we are this is are the team slide. That kind of gives you a little bit of a background of who we are and what we've done. And then from here, why is the next not working? There we go. We'd like to invite anybody who's in the Washington, D.C. area next week to come and visit us. We'll be at the OMG meeting. And every Wednesday from 6 to 8 p.m. they have a social where we can get to know each other over some food and some drinks and talk a little bit more about any of the questions that you might have beyond this presentation. And from that, I'd like to open it up to anybody who has any questions.
One more comment about that. If you want to show up to the thing, if you can give Ian an email so that we can have a registration ready for you. Because they're going to want a badge to be in the area.
And one thing I mentioned in the chat that the DIDO architecture, I believe, is a discussion document for the object management group, who, they have a lot of specifications out there. So it is a discussion. I think it's discussion. It's not working just yet, working specification. But that's why that's why we brought up the object management group and being able to attend their, I guess, a social meeting social meeting in Reston. Be something interesting. And it's not the only specification they have out there, but it's this is just one of them.
Yeah, there'll be a whole bunch of experts there.
So Ian, to start off the questions, there is a question on the from Jorge Ferrer. Do all blockchains have same performance per your analysis?
We haven't delved too much into the analysis yet. What we'd like to do is get some funding so we can add in some visualizations that we've kind of come up with that can help you come up with security grade, a performance grade, an energy consumption grade to help you really figure out which one will consume the most energy versus giving you the best security or speed that you're kind of looking for. From that, there's something called range graph that I think could be really helpful to kind of overlay how you could see the interactiveness of the different technologies. I don't know, Brian, do you input?
I would say that fundamentally at the blockchain level, due to the differences there, they wouldn't operate, they wouldn't perform the same. Something like Bitcoin versus Ethereum. Ethereum's doing a lot more processing with their smart contracts. than Bitcoin is naturally as they have smaller operations that occur on the network.
It also depends on the length of the ledger in these things. So, you know, Ethereum's had to make shards to keep the size of the ledger smaller and optimize it. If you can use one of their sandboxes, but then again, you're relying on other people's machines and other real networks. So it's hard to compare apples to apples, because the day that you might be testing, the war in Ukraine broke out, so the networks are all slow because of all the extra traffic, and so you can't figure out what's going on. Or there's a lot of activity that day. So it's really hard. Where in our environment, at least you're comparing, you should be able to do the same test over and over again. So if you decide you wanted to make an improvement, you could actually test it to see if it's actually faster. Now, it's relative faster, not an absolute. You are only measuring things relative to each other. So you could actually bring up Ethereum and Polkadot and some other networks and have nodes all talking together inside the virtual network. And they could be doing integration testing or interoperability testing between those.
Hey, folks.
Any other questions?
So this is Josh. Firstly, thanks for being here and showing us this, you know, this environment and the DIDO project and walking us through everything. I appreciate all of your time today and your willingness to do so. I had a few questions. I guess the first one is this something that's available to the community to use as well? Or would they have to, if someone wanted to use like the DIDO testing environment, would they have to contact you directly? Is it, you know, trademarked, or if you will?
Ian, if you don't mind, I can talk to this. Yeah, at the moment, it's currently where you would need to communicate with us directly. Our hope is to be able to provide this to the community, like a community distribution package. But at the moment, it's if you would like to use it, you'd have to reach out to us.
Okay. The second question then is, would you gentlemen mind dropping your emails in the chat for us so that the interested parties on this call may be able to reach out to you?
Sure. Yeah, I'm on it. I'll do it.
And when you were designing this, what sort of facets were you looking to create to differentiate this from other types of testing environments or container or siloed platforms?
I think what we're trying to do here is provide a way, well, two things. Ease of use for the user, so running the system on your own resources instead of out on a cloud service and being pre-populated with like a list of templates, and ease of communication or ease of use to create your own template for your own specific application. We wanted to be able to provide like a scenario in which that facilitates the user's case for running in their own environment. But once we get to a cloud environment, or think of like this DIDO test environment as a service, we want people to really share what they're working on as well. So eventually there could be, you know, you develop this sort of communication node, if you will, and it communicates with the blockchain over a separate domain. Our hope was that developers could then improve upon it or customize it in a different way and then share that with other developers.
I want to add in one of the things that the GE people have said when they saw our testing environment is that we are going more generic as a spin-up system, where a lot of the solutions that they saw have been very or highly specialized towards one specific solution or outcome.
Another thing is that we can do regression testing because we can. Brian alluded to it when he initialized some nodes to a value. I mean, that could be quite detailed. We just put in a simple number, but it could be quite detailed. And this means that you can do really good regression testing. You can spin up all your nodes at the same node place and start them up, and then you can apply tests to them to see if you get the same results after you've made modifications to your software. It also allows you to play back and record. So with depending on how you have it configured, not all the ways you can configure it will allow playback and record. If you have playback and record, this means that you could actually create testing environment. Testing, when I say testing, this is of like certification testing for a person. You could say, okay, what we want you to do is do this. And because you have a known state and you know what the state could be after they've done it, you can test to see how well they've done it. Or you can set up a demo that says, okay, here we're going to be doing such and such, and we play back the transactions, and then you can see how they affect the system, and someone can say, got it. So it's very hard to try to communicate to people educationally how things work when you have to do it abstractly, and if you have to have 100 nodes up there. Now, we differ from a sandbox. One of the other things you mentioned and alluded to is sandboxes. And in sandboxes, they're good, but they are you never can recreate the state because you don't know what the state is when you test. So today it worked just fine. Tomorrow, who knows? Maybe they added more blocks to the blockchain. Maybe they changed the state of some of the nodes. Some of the nodes are offline.
The number you dialed is not a working number. Please check the number in.
I don't know if my dad just cut off or what happened. Roger Boodoo came up with a good use case where you can do a patient tracking DApp with multiple NATO actors, given the current Russian-Ukrainian conflict, which I think is an excellent use case, and we'd love to talk to you more about the specifics and how we can end up using that as a future use case for us. In terms of industries that are most interested in our product, we haven't had, I guess GE Healthcare or healthcare is definitely an interest. We think that quite a few defense contractors could be interested, but we haven't quite gotten to reach out to them yet. And the DDS world in general, we think that there would be a lot of interest from the users of DDS in being able to spin up this technology and do the testing that they're interested in. We think that blockchain world can be a little difficult with the inherent libertarian ideology or concept where they want less regulation as they develop forward. So that's going to be, I think, a little harder of an area for us to necessarily dive into unless we provide a low cost solution for them to spin up and test their technology.
Also, May 22nd, we will be releasing, when I say we, the OMG will be releasing its answer to the 22 questions that were proposed in the Federal Reserve's white paper. But we are answering each one of those questions in detail. And how DIDO plays in that role.
Then we have John, who brought up the concept about gas fees. If the technology that you're trying to spin up within our virtual system requires gas fees, we can do an estimate like some of the other testers to find out how much your gas fee would end up costing you. But for us within our world, we don't. I'll let my dad talk about his thought on gas fees, because we've had quite a few talks within the blockchain PSIG at OMG about gas fees. So Dad?
Yeah, the gas fees are a really interesting problem to try to solve. The estimates that come out, like for Ethereum, they're pretty good about what it's going to cost, and that can affect your design. So when you get into do you store things on the block or don't you store things on the block? The amount of computation that's required. Computation is usually cheaper than than storage. It's really a complex thing. But if we were to spin up a consensus node that's going to be able to do consensus, you can tweak things to try to figure out how to make your blockchain more fuel efficient, as well as your contract. But you know, the consensus algorithms are the things that are taking it up. When you read about gas, it's generally about the cost of storage and distributing the things across the things. Now, some consensus algorithms are far better at gas fees than others. So, for example, IOTA and there's a whole chapter in the DIDO RA on consensus algorithms, and I encourage you to go there to read about the consensus algorithms. But they use a far more efficient way of being able to get a consensus, which means the gas fees are almost nil or not existent. So, for example, they randomly pick, I think, an odd number of nodes and then ask those nodes to verify it, and you do it in the background, and you don't know whether you're doing the validation or not, the consensus. And then based off the odd number, they decide whether that's going to move forward or not. One of the problems that we've run into with gas fees and consensus and the miners is that the miners have now become centralized. So you have these huge centralized nodes sitting in a distributed system, and they become the bottleneck and the problem. So it's all about the consensus algorithm, and you could test different consensus algorithms to see if it would work. I don't know what else to say about that, though.
I think, yeah, Gerard has a question.
Sure, thanks a lot. Thanks. It's actually a point of clarification on the last point. So while I think everybody recognizes that there are these huge mining pools that share in the block rewards, right? My understanding is the way the algorithm works is while you can have all those miners essentially connected from to collect the block rewards, the protocol doesn't actually allow them to collude with regard to the consensus. So is that when people talk about the fact that the miners are centralized in a decentralized network, I think that that's not, while it's true from a revenue generation perspective with the block rewards, I don't believe it's true from an integrity of the data perspective. So just a little point.
No, the integrity of the data. The integrity of the data is fine. I just put in the chat the link to the DIDO RA on consensus algorithms. But you're right. But what has happened is because of the speed at which people are trying to solve it, they have gotten bigger and bigger machines, and nobody, you know, if you don't have a big machine, a big data center, or whatever else, you have very little chance of being able to mine any cryptocurrency, any Bitcoin, or even some of the Ethereum. So that's why I say it's become these supercomputers that are stuck in the middle, and it's no longer the original intent, which was more democratic, or people could randomly get it. Now, some of the consensus algorithms allow for that democracy. There was a coal company. There was an old coal mine in Montana with a power plant next to it that was brought back into service so they could harvest coal to burn it, to do nothing but do Bitcoin mining.
Yeah, you know, we're gonna in the event that we're doing in May, we're doing the blockchain, the cryptocurrency energy debate. And boy, if you want to see sparks fly, that's going to be quite quite something to see. So if anybody's interested, I can share information about that later. That's going to be a lot of fun to watch.